Today we start to learn new topic which is a Docker and containerization. Docker and containerization. Containerization or the shipping the code. Shipping the code. What exactly will happen? This explain the basically how to package your messy application, package your messy application into a neat immutable box that runs exactly the same way on your laptop, your friend's PC, and the AWS server. Here is your application. You can pack this application on the box, your application, and provide this box to your friend laptop, which is WinOS or Windows OS or the Linux OS. Actually, I exactly not knowing the how I draw the tux, so I draw the simple laptop Linux OS. So it is possible to run everywhere. We have all been there. You spend weeks building a project. It runs perfectly on your laptop, and you send it to your boss or try to put it on server. It crashes immediately. Example you build the project which is related to the ML or AI ML related the project you created, or the any stuff related project you are created, and this totally working on your laptop, totally finely working on your laptop, finally working on your laptop. And in your company you need to send the code to your boss. Send a code to boss. So it is also required to run this similar code in the your boss laptop, which will be the perfectly. How actually it is happening? You send to your boss and try to put in server, and it is possible to it will be the crashing it or crashes. Possibly, might be possible. Okay. And another thing, why? Because the environment is different. Example, you running on the Linux OS, like me, you run on your program on the Omarchi OS, and your boss is still use the Windows OS. So it is possible, might be possible to your program crashes, or the system will be crashes of your applications because of the different OSs, different environment, and different library version, different dependency. These what actually different? Check it. Actually, what are the different things because of this will be possible to crashes? First is the operating system. Another second thing is the libraries. Okay, which and another dependencies of your applications, libraries which is installed for your application running, like that stuff. And this is used the hardest part of the software engineering until we decide to stop shipping the just the code and started shipping the computer itself. Okay, so before 1960, what happened the before 1960? Loading a ship was a nightmare. So floor snacks, car, then furniture were all different shapes. They came into the standard shipping container and a steel box. The crane doesn't care what is inside. It just know how to lift the box. Before 1960 there are the lots of things we need to the we need to reach to the from this location to this location, or from this location to another location, uh, using the ship or the container. What exactly will be what exactly happen that time? There are the snacks or the cars will pack on into the container, and container doesn't know what exactly inside this contain. It take this container and provide the container into provide the container from the ship into the another location. This is exactly happening like also in Docker. Docker does this code. We put your Node.js application, your database driver, and your Linux configuration inside the digital container. Now the server doesn't need to know how run the Node.js, it just needs to know how to run the container. What exactly I can say? Docker does this code. Here is the Node.js application, and another is a databases drivers and Linux configuration. It can Docker will be wrap these all things and apply inside the container first second into the container, and you need to just provide this container to any OS or the any different system, and this different system will just using the Docker will just run this container, and container automatically according to your Docker file it will be run the Docker exactly, which will be we will be checking this. Okay. But wait, isn't this just a virtual machine? Actually, in container it not just means the virtual machine. What exactly the container? A virtual machine is like a building a separate house for the every family. It has its own heavy operating system, means having the kernel, and its own the plumbing, and its own the foundation. It takes a minute to start and uses the GB for the RAM. We all of us know virtual machine is a very different thing. Not very, but the different thing, because of the there is OS, and the OS contains the kernel and its own plumbing, own foundation. It takes minute to start. It takes basically minute to start your application. You need to start the application because uses the RAM, GBs, okay, lots of stuff. And another thing which is a container is like a apartment complex, everyone shares the same foundation. What everyone will be share the same foundation. Everyone will be sharing the same foundation, the host OS kernel, which is the same foundation, the host OS kernel. But they have their own private walls. It starts in millisecond and uses very little RAM. It has the own private wall. Apartment complex having the private wall using the same foundation like the virtual machines, but it runs in a millisecond. And uses the very little also RAM, uses the little RAM. Okay, this allow you to run 50 microservices on a single laptop without it catching the fire. more than 50 or 50 microservices, possible to around 50 microservices on a single laptop. Here is the single laptop without it catching the fire, without catching the fire. Okay. um, there are two words you must know. First is the image and another is a container. Two words which you must know when you learn the Docker. First is the image, another is a container. Docker image and Docker container. Okay. The image like a blueprint. The image like a blueprint. It is a read only a file. It is a read only a file that say here is a how you build the app, like the class in coding. Here is how you build the app, like the class in coding. And another is a container. Image is like a read only file, read only file. How you build the app, how you build the app, like the class in coding, class in coding. Okay. And container is like a actual running instance, actual running instance. It's a building built from the blueprint, like object in coding. Building built from the blueprint. Building built blueprint, like object in a coding and a class in a coding. Here is similar, like if you know the OOPS concept, the class, and here is like similar the object. You can spin up the 100 container from a single image. Here are the container, lots of container. You can spin up this all container into the Docker image, one Docker image. After the running this Docker image, it's possible to start this 100 container basically. In demo, we will be checking that how actually initially for this. So we will be checking the Docker demo, how exactly will be happening in the Docker. Initially there is I will clear it and check the Docker version. Here is installed Docker version is 28.5.2, and I check the Python version installed on my system, which is a 3.13.7. But suppose I have a project which required, or the dependencies required the version which is a Python 2.7 or the related to 2, then what actually will be happening? I will initially check into my system Python 2 version. Here is the command not found, but I want it, so I run the Docker run, which is -i Python 2.7. We will be check that why -it is used in the Docker -it is used for the create, run and deploy the container is used for the creating the or the running the image. Initially they check in the locally if this image is contains or not, but here is actually happen unable to find the image Python 2.7 in locally. So it start to downloading the image from the Docker registry. Actually Docker is just like a GitHub. When you pull the in GitHub, when you pull the any repository, it install on the locally. So after that, but Docker in Docker Hub contains the image or the image, and you can pull the or pull this image, but it does not install in the locally. It install in the container, and you can run this directly the container, not the specific the image. You will be run this Python 2.7 and installing this. Check that what exactly will be happening. Actually my internet is too slow, so it takes lots of time to install it. चक्कर Docker, Docker. Here is the pencil I actually use. I want to promote my tablet. I actually use this tablet, which is a Moto Neo 60, and with this tablet they also provide the Motorola pencil. You can check this. It's not known as a pencil, it's known as a stylus. And if I roll out this, there is exactly a cell will be opening in the pencil. You can check this. Close it to internet. Okay, it is installing. Actually, I use the Arch Linux. In Arch Linux, I use Homarchy, which is created by the DHH, who are the also Rust creator. No, I will initially check that Rust creator. Who invent the Rust? Developer Gredon Hore, which is Gredon Hore. Who is the DHH? Who is the DHH? Who is DHH? Danish programmer, writer, and entrepreneur. He is the programmer, then writer, and entrepreneur, famous for the creating influential Ruby. Oh, he is not creating the Rust. He is creating the Ruby. Rails web framework, co-founding the software company 337 Signals, with makers for the Basecamp, and also create the Homarchy and which is customized the Arch Linux distribution. A successful race car driver, winning his class at the 24 hours of the Le Mans, known a strong opinion on the technology, productivity, and human work practice. Often the challenging industry strength like the focus on AI. Wow, it's great. Okay, the image will be installed. Yeah, installed. Download mirror image for the Python 2.7. Here is the SHA code. If you know about the SHA, what is SHA-256, you can check. That is a very important concept in the cryptography. I will click the ls. Before that, check the Python version. What exactly, which version is given? Python 2.7.18. I will initially test that. Python hello world. Oh no, no Python. Oh. Hello world. It's directly running. If the container is already running into, and when I read print hello world, written of Python, here it directly running. When I click on the Python, check the Python version. Here is 2.7.18, and I click the Python and start to print hello world. It exactly printed on the 2.7.18 version of the Python. I will close it and I exit from the container and docker prune the exact file. It means clear the all containers from the image. Initially yes all. Here is the given 44 seconds ago Python 2.7 the running is lots of container. I exactly run. I all prune it. It means clear all containers. Docker prune Docker system prune. It will all stop container, all network not use at least one container, all dangling image, unused build cache. It start to prune all of the which is deleted image, deleted container, deleted network. Okay, total reclaim the space 2.3.